Okay, that
Wow.
was
Quite
that
an
was a lot.
intro. I find it
Uh,
it's stressful, because it's trying to play calm music, but also you have this countdown. It's like something,
right,
something's about to happen. You can't take your eyes off the screen.
and not sufficiently meditative for my
Yeah,
taste.
no, it
Sure.
was kind of horrible. All right, well,
Well,
congratulations to everyone who managed to sit through the hold music.
yeah, William, you ready to get started?
Let's do it. So, welcome everyone. I'm William Morgan. I'm joined today by.
Hey, I'm Jason Morgan. Good to see you. No relation, however.
Yeah, let's make that clear up front. This is just an unfortunate coincidence, an unhappy accident. Today
Right.
we're going to talk about Linkerd Enterprise. I'm going to keep this pretty short. We got half an hour total, and I want to save a bunch of time at the end for Jason to give a really exciting demo. So I'll get through the non-interesting part as quick as I can. As always, feel free to type your questions either in the little widget here, or if you go to the Linkerd Slack, there is a workshops channel that we will also be monitoring. So let's see. I'm gonna press this fancy button over here. Okay, great. So let's dive right into it. Thank everyone. We're going to be talking about Linkerd Enterprise. So I've got a couple introductory slides. I'll just run through them really quick. Hopefully, if you're here by now, you know what Linkerd is: a service mesh, great open source community around it, and I'm always thrilled to see kind of all the exciting and interesting places that adopt Linkerd. Lots of contributors, startups, all the things that a health open source project needs. What service mesh? Well, there's a lot to say here. The short version is it's a lot of proxies, and we stick them next to the services. And the goal is for us to provide a set of features that are security focused or observability features or reliability focused, and to provide them, at the platform level, so the application developers don't have to know that the service mesh is there, but they get the benefits of all these features, and you, the platform owner, the Kubernetes, adopter in here, get to make use of some of the really exciting features that Linkerd provides for you without having to nag your developers to do anything different. I put in here because I really like this graphic. If anyone was with us in Chicago last week at KubeCon Chicago, we were handing out little stickers. One of the defining features of Linkerd is that the data plane is written in a language called Rust, which is a really cool language. We had a great talk by Linkerd maintainer Alex Long at KubeCon. So in that video, be sure to check it out. Called 5 Years of Cloud Native Rust. We were one of the earliest projects to adopt Rust in Kubernetes and cloud native space. And kind of one of the defining characteristics of the language is not only do you get to write code that's super fast and super light, as fast as possibly the computer can, but you get to avoid a whole set of memory safety vulnerabilities that are endemic to languages like C and C++. You kind of get the best of worlds there. You get super, super fast proxy, and you also get, you get security. You get memory safety. So, for us, that proxy, many service meshes use a general purpose proxy called Envoy written in C++. We take a different approach. We use what's called the micro proxy, really focus just on the service mesh use case, cannot be used outside. Linkerd is not a general purpose proxy, but it is very fast and very, very light. And it is security first. I found this great article written by the folks over at Google on Chrome, the web browser. They found that 70% of their security bugs were due to memory safety issues. So that's a kind of dramatic, dramatic statistic there, especially if you have a way of avoiding huge, huge class. Okay, there's a lot more to be said about the Linkerd micro proxy, but I'll leave that for another day. Let me turn off this banner here. Okay, what do you do with Linkerd? Again, I'm just going to run over this really quick because I've covered this in depth and in a whole lot of other workshops and things. Of course, mutual TLS is a big one. Gives you confidentiality and authenticity, and also gives you a framework on top of which you can build authorization. So if you like security and secure all your connections. Linkerd is a great way to do that. Another big use case for Linkerd, of course, is cross-cluster communication. We introduced kind of a variant of this in the latest release, 2.14, where if your clusters are on a shared flat network, that can be even more efficient about how we're doing cross-cluster communication. If they're not, that's fine. We'll give you this really nice and secure way of communicating across your clusters in a way that's transparent to the application, and and secure even across the open internet. So lots of cool stuff to talk about there. And I mentioned briefly authorization policy, another great use case for Linkerd. So if you want to move away from the world of network policies where you're doing things with IP addresses, of course, you can build what Linkerd provides for you is based on workload identity. And you can build authorization policies that are in the form of I'm service A and you're service B, and A is only allowed to call some methods on service B, and we did it in a way that does not trust the network at all, doesn't trust IP addresses. All sorts of interesting things to talk about here. I wrote an article at some point about zero security. So, if you search for Linkerd and zero trust, you'll get kind of a much deeper dive into all this. So, but that's all to say, Linkerd has got a great number of use cases. And I did want to spend 60 seconds before we get into the enterprise stuff, at least talking about a little bit of the roadmap, because there's some really exciting stuff. And, this spans both open source and enterprise. So I mentioned very briefly that Linkerd 2.14 gave us this way of doing multi-cluster communication with a shared flat network. We also became the first Gateway API compliant service mesh. So you are a deep Kubernetes nerd. That probably is meaningful to you. If you're not, then just know that the CRDs and kind of the configuration that we're adopting in Linkerd, we're trying to be as standard as possible, and we're converging towards this really interesting thing called the Gateway API that will allow you, in the fullness of time, will allow you to configure not just your service mesh, but also your ingress solution with one set of CRDs that are already on your cluster. So we don't have to introduce a bunch of new CRDs. That's good for us.
William, before you go too far, can you explain what that flat network multi-cluster gets us?
Yeah. So, historically, and let me go back to this gateway thing here. So, historically, the way we started out with cross-cluster communication was we have a multi-cluster gateway that we install in the destination cluster. So we say, okay, if you're cluster A and you're cluster B, and B is kind of the destination cluster, we add a little gateway there, and A and then send traffic to B. And the only requirement that we have in the underlying network is that gateway IP address is reachable. So this means that you can do multi-cluster communication, across clouds, or in a hybrid environment. We really place the bare minimum of network requirements. However, the reason we started here because the original set of use cases we saw for multi-cluster Kubernetes communication, this was circa 2018, 2019. Was kind of a very ad hoc one. Okay, we had this cluster here, and then we had one over here, and maybe we absorbed another company, and all those you ended up with this set of clusters that weren't really planned ahead of time. What we're seeing now is a much more planned approach to multi-cluster, where we'll see companies coming into this and say, actually, I'm going to have 70 Kubernetes clusters, and I'm planning this in advance, and I'm going to have the network set up, in this kind of shared way. And so what it means is shared flat network basically means all the pods in those different clusters can route traffic directly to each other. So they don't know about each other. Like, there's no service discovery that's being shared by Kubernetes itself. But if you give them an IP address, one pod from one cluster can talk to the other IP to the other cluster. So in that world, Linkerd 2.14, we can give you that same safe and transparent level of multi-cluster communication, but we don't have to have the gateway. There's no gateway. So that means it's a little bit faster. It also means you get some nice features like the identity preserved. So the source identity, makes its way all the way to the destination identity. So you can have very rich, powerful security policies that allow certain clusters or certain services only on certain clusters, or however you want to slice it.
All right, awesome. Thank you.
You got it, Jason. Great question. as a reminder to anyone who is listening in from home, you can, if you have questions about any stuff, you can dump them into the workshops channel on the Linkerd Slack, or you can dump them, into whatever, mechanism you're using to view this. I know we're streaming across a couple platforms, and I will do my best to address those questions live. If they're easy, I'll answer them myself. If they're difficult, I'll have Jason answer.
Perfect.
All right, so that was 2.14 that we just talked about with the new form of gateway, gateway-free multi-cluster communication. 2.15 is a big target for us. And I've got another slide where I'll get more into this. And we talked a lot about this at KubeCon. So the goal for us in Linkerd 2.15 is mesh expansion, which means being able to bring in non-Kubernetes resources, such as workloads that are running on VMs, into the mesh, give them the same security and reliability and observability guarantees that we can provide for in-cluster communication to that, half in, half out communication. And then 2.16, I'm not going to talk too much about, but that's starting to shape now, and we're going to be telling things like ingress traffic and giving the ability to control egress traffic, so traffic coming into and out of the cluster. So 2.15, I'll spend one slide on this and happy to answer questions. Again, this is going to pertain to both open source and also to Linkerd Enterprise. Basically, add support for non-Kubernetes workloads to Linkerd. So the control plane still has to run on Kubernetes, but the data plane itself can be both within the cluster and outside of the cluster. And it's kind of 4 challenges. I don't have a link to it, but I also wrote a blog post about this last week with a few more details. Kind of four challenges to mesh expansion for Linkerd. One is around identity. So how do we determine the identity of a workload? Right, in Kubernetes, we can use a service account because that service account basically determines, for security purposes, your identity or the identity of the workload. Outside of Kubernetes, we don't have anything. Right, service discovery is another challenge. Inside Kubernetes, it's doing all the service discovery. It is maintaining, Kubernetes itself is maintaining all the service discovery information. Kubernetes can listen to the Kubernetes API. It can get updates. We can keep in sync. Outside, it's the Wild West. Maybe you've got DNS at best. Network connectivity is known, right? Within the cluster, you kind of have all these guarantees that any pod can talk to basically any other pod, and let's set up network policies outside the cluster. Of course, we need some way of establishing connection from the proxy, from the micro proxy back to the control plane. And then finally, there's a challenge of runtime, right? Within Kubernetes, if you start up a pod, we have all these tools, mutating admission controllers and things like that, where we can inject the product automatically for you. We can configure it. We can have a init container that sets up the L3, L4 networking for you. Outside of Kubernetes, we can't make any of those assumptions. So this is all to say mesh expansion is non-trivial because we have to solve all these things in Kubernetes land. They're kind of solved for us. Outside, we have to come up with our own mechanisms for doing this. The identity one is the most interesting one, I think, probably the most interesting from my perspective, at least. We're going to make use of a project called Spiffy. Who are familiar with the kind of cloud native ecosystem. That project's been around for quite a while, almost, I think, as long as Linkerd has. Really well-established way of being machine identities and identities for things, are not necessarily running on Kubernetes. So we'll just piggyback off of that. So it's going to be super cool. I'm really excited about this. There's definitely a lot of Linkerd adopters out there who have been asking for this for quite some time. So that's a little hint of to come for Linkerd 2.15. Okay, any question before I dive straight into enterprise land? Any questions from you, Jason?
No, looking okay so far. Well, actually, one at KubeCon. Did we see the folks at SUSE demonstrating this mesh expansion functionality?
We sure did. There's a great partnership we're doing with SUSE around Internet of Things. There's a lot of really exciting stuff happening in the Linkerd universe these days. So yeah, if you want to learn more, either ask a question in the workshops channel or just follow me on Twitter, LinkedIn, or something. I'm full of Linkerd related news.
And one more, if folks do have opinions or thoughts about identity and mesh expansion, what's the right way to connect with the Linkerd folks on that?
Yeah, great question. So if you are interested in this, then please find us either on the Linkerd Slack, which is slack.linkerd.io, or you can just email Jason or myself directly. Our email addresses are our first names at buoyant.io. Just make sure you spell Buoyant correctly at the top right of the screen. So, don't mess it up. But absolutely, would love to hear from anyone who is interested in this. We're in kind of prototype phase with mesh expansion, so it's not too late to get requirements and questions in. All right.
And for folks that
go ahead.
For folks that are interested, that article that William talked about is available here in your chat if you're over on YouTube or over on the workshops channel in the Linkerd Slack. So
that's my mesh expansion article.
Correct.
Or if you just for Linkerd mesh expansion, you'll probably find it as well. All right, great. Let's talk about Linkerd Enterprise. So what is this beautiful creature that you see before you? So Linkerd Enterprise is a new proprietary distribution of Linkerd created by Buoyant, the creators of the Linkerd open source project. And the goal here is we want to have everything in open source Linkerd plus a couple extra bits in here. So when you use Linkerd Enterprise, you get enterprise hardened images. So these are a separate build pipeline with additional testing, additional scanning, things like that. You get software bills of material for your compliance team, gives you the provenance of every component that goes into a particular image. You get SLAs around CVE remediation. We've never really been able to sign up for that in open source land, but with a dedicated build pipeline, we can do that. So that's kind of the compliance bits and bolts. And then we have some enterprise-only features. This is where things get really exciting. So FIPS compliance is in the enterprise distribution. If you are selling things to the U.S. federal government, then that's very, very important for you. If you're not, then trust me, you don't want to know anything about this. It's horrible. But it's available. Lifecycle automation, another one for us. I'll talk very briefly about that. Cost optimizing routing, that's the most interesting, I think, today, since everyone is trying to cut costs. Jason's going to give a demo of this at the end, if I ever shut up. And you'll see some really interesting stuff we can do there. Security policy generation. There's a couple other things in here that I think are really interesting. The goal is, that none of this should affect open source Linkerd. These should all be features that are really, really interesting and important when you are an enterprise adopter, that really are not that interesting and important if you're in other situations. So Linkerd is the world's simplest, lightest, fastest service mesh, probably the most secure too. And we all remain committed to keeping that promise to our open source use. Nothing about this changes. Linkerd Enterprise is a way for us to serve the unique and sometimes horrible needs of our enterprise customers, and nothing about that detracts from our core mission. And I talked about the roadmap ahead of Linkerd. There's some really, really exciting stuff, and nothing out. Enterprise means that that roadmap gets detracted from it all. So I know sometimes people are nervous that suddenly they're being in different distributions. Don't worry, I and all of the Linkerd maintainers are more excited about Linkerd than ever before.
So we're not taking Linkerd private then?
Yeah, nope, not taking it private, not taking it off the market.
Right. Okay.
Okay, let's run through a couple of these open source, these enterprise features. Lifecycle automation is a cool one for us. Upping Linkerd is pretty easy, but we can make it even easier with an operator. And the operator automates not just upgrades, but installs, rollbacks, a bunch of other stuff. Automates that across the control plane and the data plane. So if you can manage a really large fleet of Linkerd installations, it's going to be a huge saver of time, toil. It's completely compatible with whatever GitOps mechanism of your choice. Argo, Flux, Helm, and yeah, this is a really nice one. Another enterprise feature for us, and this is kind of the beginning of a longer roadmap here, policy generation. Linkerd has such a rich and powerful set of security policies built on workload identity, enforced at the pod level. It's like everything you want for zero trust. Getting started with those policies in an existing system, especially a large system with lot of existing communication. So we can actually generate some of these baseline policies for you based on a bunch of specifications, based on live observed traffic, and we can do some really, really cool stuff around here to make it a lot easier for you to implement these policies across the entire stack. The Buoyant Cloud dashboard, there's a lot to say about this, but I'll just give you some of these razzle-dazzle screenshots. Suffice it to say, really, really sophisticated multi-cloud dashboard. Also has a whole set of alerting and monitoring built into it. So again, if you are running a large fleet of Linkerd deployments, you have a comprehensive set of monitoring tools that hooks right up to PagerDuty or whatever mechanism you want to get alerted, and you can rest easy at night knowing that Linkerd is safe and sound, and you'll get an advance notice of long before anything escalates. All right, and then finally, the kind of the fun one to talk about is this cost optimizing routing. So this is a new load balancer that we've added to the enterprise that can reduce the traffic across zone boundaries while preserving your HA guarantees. And like doing both of those at the same time is kind of the interesting bit. So if you're running a large not large, even if you are running a multi-AZ cluster, and you have non-trivial traffic going across those zones, and you look at your cloud bill, you might realize that, gosh, I'm a lot of money for cross-zone traffic. Multi-AZ clusters are practice for many cloud providers, but to do that, you have to pay for all cross-AZ costs. So we can do something really fancy here. We can remove all of the traffic from across zones until the system goes under stress. When the system goes under stress, we add those cross-zone endpoints back in, wait till things get healthy, and then we remove it. So we really can give you the best of both worlds. So today you're kind of on the left, right? Traffic is going in your cluster kind of randomly distributed. That's for HA, but terrible for cost. We can move you to the right where you have things partitioned nicely between zones. And in fact, this also works across clusters. So if you have multiple clusters in the same region, but communicating, with multi-cluster communication, we can preserve cross-cluster. We can preserve the zone for cross-cluster calls too. So for some of our customers, this is literally millions of dollars a month saving. So it can be really, really significant. If you are a deep Kubernetes nerd like Jason, then you're aware of topology hints, or I think what they call more recently topology-aware routing. This is a really interesting thing to look into. Is a very crude mechanism. If you look under the hood of how it works, it's a static approach where you take the IP addresses, you take the ports, and you partition them per zone. So you get no cross-zone traffic, but you also sacrifice your HA entirely. All sorts of conditions under which this doesn't work. Very brittle approach, but it's kind of all you can do at Kubernetes level anyways, because you don't have anything beyond layer 4 information. So if you're in the situation like Linkerd, where every request is something that you are actively routing, and you can be a lot fancier. I do have some kind of cool graph here, but really Jason's going to show us the more interesting. I'll just show you kind of like visually, this middle period is a period of stress for the system. So on the left, we have basically everything is within our load band and everything is happy and we don't have additional endpoints. In the zone, in the stress region, we add additional endpoints from across the zone. And then when the system turns to normal, everything back to single zone traffic. Jason's going to do much better demo of this than my images. And so with that, Jason, barring any further questions, why don't I turn things over to you?
All right, sounds good. Can you see my screen okay, and can you hear me okay?
I can.
All right, awesome. We'll hope that you're a good stand-in for whoever's out there on the internet. So let's talk a little bit about what we're seeing. So I know it's a terminal with a lot of stuff going on, but what we're going to show today is how cost-aware routing works. I'm using a local setup. So I've got a K3S cluster running local on my machine. And what I have is each node on my cluster represents a different availability zone. So I'm spanning availability zones A, B, and C. I have a front-end application called Brush, which talks to the Paint service. The Paint service is backed by either blue, green, or red pods. And each one of those pods is set to run in a single availability zone. So I can see when, right now by default, if we look up top, we can see that Brush here, this service, is sending traffic to all the paint pods, right? So blue, green, and red are each getting around 30 requests per second each, because blue or Brush typically runs about 100 requests per second. The core load balancing in Linkerd tells you to just kind of distribute it across whatever pods using our exponentially weighted moving average um, load balancer algorithm. What we're going to do now is we're going to change the algorithm. So we're going to go ahead and mark the paint service as being set to be cost aware. So this happens on a per service basis. And just for a little bit of insight, right now we can see that Brush is running on agent 0, and red is also running on agent 0. So when I turn this on, well, let's actually just do it, and then we'll talk about what's going to happen. We're gonna see me sweat for about a minute while we wait for the metrics to shift, right? And then we're gonna see traffic go from, being fairly evenly balanced between blue, green, and red to all running on red. And that's happening a lot faster than it usually does, which is very nice for me. So you can see the request starting to climb up, the RPS uh, on red, because right now the Brush pod, it sees that it has an upper and lower band for how much traffic should be in flight before it starts adding in pods from outside of the zone. And at 100 requests per second, Brush is happy to send everything to red because it can get the responses in a timely fashion, which is pretty cool, right? So right here, with no configuration changes at the cluster level, with no big shift other than marking a simple annotation on my service, I'm able to cut that cross AZ traffic cost pretty dramatically for this environment. But when we're reducing these costs, like, we run 3 AZ clusters for a reason, right? Like, I want green and blue to be there to serve in the event that I have a traffic surge or something happens to my red pod. I don't want to start losing requests. So we're gonna go ahead and change the number of requests in flight. Just make it look like we're having a traffic surge. William, any questions before I go any further?
This makes a ton of sense to me, Jason.
Great. It's almost like you've seen it before. So what I've got here is a little config map, and this config map essentially tells Brush how many requests to send. I'm going to 3x the traffic. So going from 100 requests per second to 300 to simulate, again, like a spike. So our app is in demand for some reason, which is great. And we make the change. And what we're going to see now is the number of requests are going to change. And as we do it, that red pod that we're looking at is going to become too saturated to continue serving all the traffic, right? So now that Linkerd proxy on Brush is intelligent enough to see, hey, it needs to send some percentage of the requests out of zone and over to blue and green. And that'll usually, the metrics are about a minute behind, so we'll give it a second to catch up. And there we go. We're starting to see that request count, uh, increment, and green starting to get some traffic, and in a minute you're going to see blue start to get some traffic as well, as these pods struggle to catch up to the amount of traffic out there. Now, so what we've got here is exactly the behavior you want to see, right? I route in zone when possible, or my proxy routes in zone when possible. But when I start incurring that cost for going across availability zones, I'm doing it for a reason. I'm doing it for availability and performance reasons. It's exactly what I'm looking for. Now, just to see, what do we do in the event that we're clever and we set up an autoscaler, right? We can actually scale. To scale our red deploy. So imagine I've got a little autoscaler. I see that the new pods are coming online, and oops, I should have said something. I don't type it live. All right, so I scaled my red deployment up, and I get 2 new pods. A lot of change is occurring here, But the big one is I have 2 more red pods getting scheduled. They're all because they have a zone affinity. They're all getting scheduled in that same AZ as our brush pod. And now we see them come online, begin to gain traffic, and that traffic drains out of blue and green because the proxy can now send all in zone. Right. So it's a neat demo, but like a lot of Linkerd demos, it's fairly unexciting because the stuff we have just kind of works the way you'd expect it to work.
Well, it's
Right. I
exciting to me.
didn't say again.
It's exciting to me, Jason.
Oh, good. Yeah. Um, over the next minute, we're going to see all the requests drain out of blue and green as that little history of the number of requests clears out. And we've seen now we have around 300 requests per second hitting the pods over in that red deployment, right? And that's where all that traffic is shifted.
So this is a really dynamic system that can respond on the fly to changes in traffic level, changes in number of pods available to serve the traffic, latency of those pods. Because Linkerd knows where every request is going and exactly how long it's taking and how many requests are flight to a certain pod, you can make these very sophisticated decisions where it's balancing HA versus the zone affinity.
Yeah, that's exactly right. Right. And now we can see with that current setup, all our traffic is on red. Overall, the only configuration we had to do in this case was tell Linkerd that that particular service is eligible for cost-aware routing, cost optimizing, cost optimizing routing.
Now, in this case, we put the system under stress by adding a lot of traffic to it. Would the same behavior happen if there were other forms of stress, like maybe some of the pods were becoming high latency or failing or anything like that?
Absolutely. Absolutely. So you can kill pods, you can increase the latency, and again, as that service becomes slower, right? The number of requests in flight changes, and Linkerd, the proxy, then begins to send requests over to the other availability zones, and then automatically adjusts when the circumstances change. So it biases you towards the availability zone that the call originates from, but it doesn't force you to stay there. And I think that's it for the demo. Thanks everybody. Thanks everybody for taking time for the webinar. William, are there any parting thoughts you want to leave them with?
Well, I think what you saw today was a really interesting demo of some of the sophisticated load balancing features that are available on Linkerd Enterprise. If this is interesting to you, if you have a multi-zone cluster with a lot of traffic across it, like we save some of our customers literally millions of dollars. Please reach out. Would love to tell you more about this. And there's a lot more to say Linkerd Enterprise, but this is kind of the overview. So thanks everyone for attending here. Thank you, Jason, for another spectacular demo. You know how to find us. We'll be on the Linkerd Slack, or you can hit us up, first name at buoyant.io. That works for both me and for Jason. Really appreciate everyone's time today.
Thanks, folks.